code from here. I have a file name as hist_net, which has the code for the file, which has a code, and it is using the library pybus to draw the graph and to visualize and simulate. So for the very first line here, I have an array which is used to generate different random number colors. So whenever there is a new node, I can use different colors for that. So which is a requirement of the project. And then I have that get data file, which basically it is actually getting the file as a file name, and then it is looking for the line. So every line has a backslash and at the end of it, so I'm splitting it on that condition, and after that in every line we have a tab which is separating the router ID and its connecting node. So with that thing I am actually getting different two different node IDs. So one is actually on the first column, it is the node ID, and the second column is the node to which it is connected to. With that, I get a data frame. I get that data frame into the edge data, and after that, I use two different colors for the first source, and I start populating the graph. I have the source ID and the destination ID, which is the column 0 and column 1 of that data frame. And I'm using two different colors for the source and the destination. This is where I'm adding the nodes to the data, and with different colors. You can see the colors with that shade array in which 0th index and 1 index have two different colors. And after populating that, I'm actually making an edge from the source to the destination, and with the value of 0, because currently I don't have any connected nodes with any of the edges, so I'm using the 0 as the weight, and then later on when I have the whole graph ready, I'll edit that value with the actual weights of the node. So in that line, we have basically that get adjustance list is basically give the adjacency list of each node with the node that it is connected to, and which I can use for calculating the weights of the node later on. So within that loop, I am actually adding the weights to the node, as well as I am updating the title of the node, so I can get to know the node ID, weights of the node, and the neighboring nodes that node has. So this first node with the subscript of value is basically the one which carries the weight of the node, and then you have node with the subscript of title, and that title actually carries the title of the node which has the weight of the node, uh, ID of the node, and the neighboring nodes that it has. So whenever you hover on any of that node in the graph on the HTML file, you are going to get those values, and you have seen that probably in that video which we made separately. So that's what it is. So after that, .NET is our graph which is populated with the nodes, and then it will show the result into that HTML file, which we will see over here. So you can see that we have net nodes 1000, which is not here right now, so I'm gonna run that code and it will have that file ready. So while that file is getting ready, I can give you a look around of the histogram that we made. So in that we are reading the file. It is basically the same code that we used in that graph. And after plotting that, after populating that graph, we are basically normalizing over here. So what that function does is basically it takes the graph, and it takes the graph and gives the histogram populated value of each of the node with respect to the weights of it. And with the weights, we normalize that graph right here. So what normalize does is basically it takes the uh, frequency of each of the weight and then it divides it with the total number of the weight. And after doing it, we are actually plotting the histogram. So this is the function it is getting the x and y values. So we are plotting it over here with that labels on x and y axis, and I'm using log on y scale. And after plotting this and running that code, I get the inputs, I get the output something like this, in which we have over log scale values on the y-axis and we have degree of the node on the x-axis. So